If you have specific questions, even while I'm in the middle of explaining something, then go ahead and send me a message through Remind. I'll have that up and ready to go. So if you need a specific question, then please go ahead and send that in Remind. Okay, there is going to be a little bit of something weird that's going to have to happen. So first period, and I apologize, this is 100% on me. Okay, when I wrote this out first period for you guys, I wrote this as x squared minus 3x minus 10, and I didn't realize that's what I'd done. So then when I retyped it for third period, I wrote plus 3x minus 10. So third and eighth got a plus 3x minus 10, and first got x squared minus 3x minus 10, which is going to be kind of confusing because that means any problem that has h of x in it, I'm going to have to do twice. But it's not going to be too terrible, so we'll make it work. We're going to start with problem 2. The good thing is everybody's problem 2 is exactly the same. So that's where we're going to begin. Actually, let me add in a better copy of this because this copy is really blurry. So give me a second. I saw this on here, Module 10 review. There we go. Oh, look, it's a much better looking copy. Maybe, maybe not, maybe a little bit. Okay, we're going to go with it. We're going to start with problem 2. So problem 2 says that we're supposed to do g of x, which would be this function here, minus f of x, so minus this one. So I'm just going to rewrite everything that I know. So g of x is 4x minus 8 over x squared minus 4. We have minus, and 3x plus 9 over x squared minus 7x plus 10. So again, one of the things we talked about today that makes the addition and subtraction more complicated is that we have to find common denominators. So that's the first thing we have to do, is we have to figure out what our common denominators are. In order to do that, we need to factor. We've got to figure out what our actual denominators are. So that means that I'm going to replace x squared minus 4. Sorry, let's change that to white. X squared minus 4 factors into x plus 2 and x minus 2. And I can also factor x squared minus 7x plus 10. And that becomes x squared minus 2x, sorry, x minus 2x minus 5. So that's my new denominator over here, x minus 2 and x minus 5. So I need to get common denominators. I've got to figure out what it's going to take to make my two denominators congruent. Two denominators equal, I guess would be a better word. So that means that on the left side, and here's something I've been noticing as I was grading and something y'all were doing that was very interesting to me. Don't forget to factor this, because y'all end up doing a lot more work when you don't factor, because you end up multiplying by things that you don't actually have to multiply by, and then you get bigger answers than you need to get. So make sure, always, always, always make sure that you factor this denominator so that you can make sure that you are simplifying the polynomial as much as you possibly can. That just makes your life a lot easier to look at the breakdown pieces, the most broken down pieces. That will help out a lot. So we've already factored that, and the factoring is helpful because we can see that both of these have x minus 2. Sorry, both of them have x minus 2. So I don't have to worry about that. All I have to figure out is what's different, what are the discrepancies there, and then multiply by that. So that means that I need to multiply the fraction on the left by x minus 5. And again, if you have questions about what I'm doing as I'm going through this, please text me and Remind. I've got Remind up and running. I'll be checking it, so just to make sure that I don't miss anything. But if you're like, hey, I don't know where you got that, I don't know what you did, please message me, because it doesn't do any good if you just take my word for it and don't actually understand where it came from. So that gives me on the left side my new fraction. If I distribute that in, that would give me 4x squared. I'm going to do a little bit of math here and kind of jump ahead. Minus 28x plus 40. I got that because I went ahead and distributed x times negative 8, which would be negative 8x. Negative 5 times 4x would be negative 20. And when you combine those together, you get that negative 28x. And then, okay, on the right side, need a new color here. So let's go with pink. It's a good one. So for this fraction on the right, I need to multiply the numerator and the denominator by x plus 2, so that now my denominators are completely identical. So I'm still going to have that minus sign in the middle. So minus. And then if I do foiling over here, I have 3x squared plus 15x plus 18. Again, I just went ahead and 3x times x, 3x squared, 3x times 2 is 6x, 9 times x is 9x, and I can combine that 3x and that 9x together to give me 15x. And then 9 times 2 is 18. I'm going to go ahead and for now I'm just going to keep this as two separate fractions. I'm going to combine it in a second because I need you to see what math I am doing. So we have our denominators of x minus 5 times x plus 2 times x minus 2. And that's true for both of them. I can go ahead and I can start combining, but remember I have this minus sign in the middle, so this minus sign is going to throw things off a little bit. Not too terribly bad, but it is definitely going to make some things a little more complicated. So when we combine these together, we have our 4x squared that we can combine with our minus 3x squared, and 4x squared minus 3x squared is 1x squared, so I'll have x squared. Then we have negative 28x minus 15x, so that's going to give negative 43x. And then last we have 40 minus 18, and that's going to give us 22. So whoever it was, someone asked me, hey, Miss Grimm, I think you got problem number 2 wrong. You were correct. I did. I don't remember who that was, but thank you for finding my mistake. I appreciate it. So this should be my answer. It's almost my final answer. The only thing that I need to do now is I have to make sure that I figure out my excluded values. My excluded values come from my factors of the denominator. I need to figure out where those would be equal to 0. So I've got 3 different factors in the denominator. And so start with x minus 5. That means x can't be 5. And then my next one is x plus 2. That means x can't be negative 2. And the final one, x minus 2, means that x can't be positive 2. So that is problem 3 in its entirety. And that is, I'm sorry, problem 2, I apologize. That is the final answer to problem 2. Again, just looking to see if I've gotten any questions on Remind. So that was problem 2. Thank you to those of you that are watching right now. Appreciate that. I said I was going to do problem 3 next. Oh, nope, 4. I was going to do 4 because 4 is an addition problem. Okay, so when we are adding, we again have to worry about common denominators. The good thing is that problem 4 and problem 3 are pretty much the same, except the difference is problem 4 has a plus sign instead of a minus sign. So I'm actually going to kind of skip a step. I'm not going to go through all this process again because it's going to be the same. And I'm going to jump down to this step right here. So I'm going to go ahead and bring that step down, and I'm going to rewrite that problem as 4x squared minus 28x plus 40 over x minus 5 times x plus 2 times x minus 2 plus 3x squared plus 15x plus 18 and, over, forgot to write the denominator, that kind of helps, over x minus 5 times x minus 2 times x plus 2. So this time I am adding, I'm trying to combine these things together, but that's pretty simple when it comes to addition because all I'm doing is just adding my like terms together. So that means that I can combine some things. I can combine my 4x squared plus 3x squared, which is going to give me 7x squared. And I have negative 28x plus 15x. That's going to be negative 13x. And then I have 40 plus 18, which is going to give me 58, divided by x minus 5 times x plus 2 times x minus 2. And again, just figuring out my excluded values, what x cannot be. So that comes from the factors of my denominator. So that would be positive 5, negative 2, and positive 2. So that is my entire answer for problem 4. Okay, I'm getting a couple questions in our minds. I'm having to go back and read stuff and see where we are. All right, so the next question that I'm going to do is problem 5. Problem 5 is a division problem. Okay, and here's something that's important. I'm going to have to do problem 5 twice. I'm going to have to do problem 5 once for 3rd and 8th period and once for 1st period, because 1st period I gave y'all a different denominator for h of x than I gave to 3rd and 8th, and I didn't realize that till the middle of the day, so that was fantastic. So for 1st period, the function we're going to work with is the denominator is going to be x squared plus 3x minus 10 here. So it's just going to change our answer a little bit, but it's not going to change our process. But I will do this problem twice. So it says I have f of x, which is my 3x squared plus 9 over x squared minus 7x plus 10. Oops, sorry, let me zoom in here. Okay, so right now I'm doing this for 3rd and 8th, or anybody who got the review after 1st period. If you got the review during 1st period, then this is not going to help you out. I'll do that one in a second, but this is for anybody who got the review after 1st period. So x squared minus, sorry, gotta look back at the problem, 3x plus 9 over x squared minus 7x plus 10. And then I'm dividing that by, and I'm going to fill this in, 2x squared minus 6x minus 36 over x squared minus 3x minus 10. Okay, I wrote that problem down so I won't have to keep zooming back in and out. Alright, so I have 2x squared minus 6x minus 32 divided by x squared minus 3x minus 10. Again, I'll do this in just a second. I'll do it again in a second, but the next time I do it, I will change my denominator here. Okay, so when I need a factor. That's what I need to do. Oh, no, sorry. Let's start over. Let me get my train of thought. People are texting me and reminding, it's throwing me off, which is fine. I appreciate the messages, but definitely kind of throws me off for a second because I have to switch my brain around. So I'm going to rewrite this, instead of a division problem, I'm going to rewrite this as a multiplication problem. 3x plus 9 over x squared minus 7x plus 10 times, and then I flip this fraction on the end, minus 3x squared minus 3x minus 10 over 2x squared minus 6x minus 32. And then I'm going to factor. So we start with 3x plus 9. I can factor to 3, and I'm left with x plus 3 over x squared minus 7x plus 10. That factors into x minus 2 times x minus 5 times, I have x squared minus 3x minus 10. That factors into x minus 5 times x plus 2. And then 2x squared minus 6x minus 32. That factors and then factors again. It factors into 2 times x minus 6 times x plus 3. So again, that factors out twice. That's important that you note that it does factor twice. So just pay attention to that, because I took out the GCF, everything was divisible by 2. That's where I got this, and then I'd be left with x squared minus 3x minus, that should not be 32, sorry, that should be 36. That would make things look a little better. That should be 36 there. So this leaves me, when I factor out the 2, I'm left with x squared minus 3x minus 18, which factors into x minus 6x plus 3. So then I'm looking to see if I can cancel anything out, things that are the same in the numerator and the denominator. Well, in both of them I have an x plus 3, and I have an x minus 5. There's nothing else that's the same in both, so I can go ahead and I can multiply this back together. So I have 3 times x plus 2 over 2 times x minus 2 times x minus 6. It's helpful just because it's easy to do, to go ahead and distribute this 3 out, just because it's not complicated. And I end up with 3x plus 6 over 2 times x minus 2 times x minus 6. So that's my answer. I just have to figure out what my excluded values are. So the big thing is, remember, excluded values come from anything that was in the denominator at any point in time. And I had several things that ended up in the denominator. So one of the things that was in the denominator was obviously my x minus 2x minus 5. So I have excluded values of x cannot equal positive 2 and positive 5. Obviously this was in my denominator, 2 times x minus 6 times x plus 3. So that means I also have an excluded value of positive 6 and negative 3. And also, this numerator was originally in my denominator before I flipped it. So x minus 5 tells me there's an excluded value of positive 5. I already have that one. But x plus 2 tells me there's an excluded value of negative 2. So that is my entire answer to question number 5. Well, for 3rd and 8th period. Okay, so I'm about to redo this problem, but this time when I redo this problem, I'm going to change the problem a little bit. Yes, and I'm going to change the problem because the first period I gave a different problem, and I'm really sorry about that. I didn't realize I had done that, so I apologize. So the problem I gave to first period, and I'm going to start at this same step here, was 3x plus 9 over x squared minus 7x plus 10 times x squared minus 3x minus 10, plus 10 over 2x squared minus 6x minus 36. Again, this is the problem that I gave to first period. So if you're not in my first period, then this problem has no bearing on your life. So Yay for you. So I'm going to redo this problem, but this time I have a different fraction in the top. I have x squared plus 3x minus 10. And I apologize for that. I really did not mean to do that. I thought I'd fix it to be the same, and obviously I had not. So I'm going to go through again. I'm going to factor just like I did before. That's not going to change. So we have 3x plus 9. I can factor 3 out, and I'm left with x plus 3. And then x squared minus 7x plus 10. That again factors into x minus 2 times x minus 5 times, this factors, x squared plus 3x minus 10 is going to factor into x plus 5 times x minus 2, and then divided by, and I can factor 2x squared minus 6x minus 36, and that is going to become 2 times x minus 6 times x plus 3. And again, I got that because there's a GCF here that I took out, and once I took that GCF out, I was able to factor that again. So I'm looking for things that I can cancel out, things that are the same on top and bottom. So again, if you're just now tuning in, I'm working this problem out for first period. If you aren't in first period, then you're not going to know what we're doing because you don't have this x squared plus 3x minus 10. But in first period, I told them plus 3x, and in third and eighth period, I told them minus 3x. So that's my bad, so I'm just working out both problems. It's going to be okay. So first period, we're still working that one out. I'm going to cancel out the, let's see what cancels. Ooh, my x plus 3's cancel. And also my x minus 2's are going to cancel out. There's nothing else that cancels, so I'm left with 3x plus 15 divided by 2 times x minus 5 times x minus 6. So that one, there was a mistake on y'all's answer key for first period as well, and I'm sorry I didn't catch that. I did a really bad job this time, guys, and I apologize. I'm not on top of my game, obviously. Sorry. I promise I really do try and be better than this. So I've got my answer. I need to figure out what my excluded values are. So what they can't equal comes from everything that was ever in my denominator at any point in time. So starting with x minus 2x minus 5, x can't be 2 or 5. Then going to 2 times x minus 6x plus 3, that means x can't be 6 or negative 3. And then also don't forget about your x plus 5x minus 2, because that was originally in the denominator. And that means that x cannot be negative 5. So that is my entire answer for problem 5 if you were in my first period class. Okay, if you're in third or eighth period, or you got your review later in the day, this is your answer. If you're in first period, this is your answer. Okay, so I've done, let's see, what have I done? I have done a subtraction, an addition, a division. Now I'm going to do a multiplication. So I'm going to do problem 6. Okay. Okay, problem 6. So again, I'm going to have to do this one twice. Okay. I'm going to have to do this problem twice because I'm going to have to do it once for first period and once for third and eighth, but it's not going to be too bad. So for this one, we're multiplying all of our terms together, f of x times g of x times h of x. So the good thing is that multiplying is easy. Doesn't matter how many terms you're multiplying together. The multiplication part is pretty simple. So this time I'm going to do the problem for first period first. Okay, so for first period, anybody who got their review during first period, we have f of x, which is 3x plus 9, over x squared minus 7x plus 10, times 4x minus 8 over x squared minus 4, times 2x squared minus 6x minus 36 over x squared plus 3x minus 10. Thank you, Lexi, for making me laugh. I appreciate that. All right, so I need to factor everything I can possibly factor. So let's start with 3x plus 9. So 3x plus 9 factors. It factors well. It factors nicely into 3 times x plus 3. That denominator factors as well. X squared minus 7x plus 10 factors into x minus 2 and x minus 5. Okay, then we have times. We can factor 4x minus 8 because I can factor out 4. So I'm left with 4 times x minus 2. I can factor x squared minus 4. That factors into x plus 2, x minus 2. And then we can factor 2x squared minus 6x minus 36. That's 2 times, we already said earlier, x minus 6 and x plus 3 over, and then we can again also factor our x squared minus 3x minus 10, plus 3x minus 10, I'm sorry, into x plus 5 times x minus 2. So again, I'm just looking for things I can cancel, things that are the same. So anything that's the same on top and bottom, I can factor. So, or I can cancel out, sorry, not factor, I can cancel. I can cancel out an x minus 2. And I believe that's the only thing that's the same on top and bottom. So that answer ends up being 24 on the numerator, because I multiplied 3 times 4, which is 12, times 2 is 24, times x plus 3 squared times x minus 6 over x minus 5 times, x minus 5, yeah, times x plus 2 times x minus 2 squared times x plus 5. The denominator looks pretty ugly just because of how big it is and how nothing canceled out, but that doesn't mean that we can't use it. So now we just need to figure out what our excluded values are. We've got to figure out all of our excluded values. So we start with what we still have in the denominator. X cannot be 5, x cannot be negative 2, it cannot be positive 2, it cannot be negative 5, and that's it, because the only other thing that was in the denominator was this x minus 2 here, which we already had another one here. So these are my excluded values. This would be my entire answer to problem 6, and that is for those of you who got your review during first period today. Okay, so now I'm going to do the problem again, but this time I'm going to do it for everybody that is in my review later on during the day. So again, we have our same, we start off the same, 3x plus 9 over x squared minus 7x plus 10, and times 4x minus 8 over x squared minus 4, times 2x squared minus 6x minus 36 over x squared plus 3x minus 10. So I'm looking for, I need to factor everything, which the stuff factors the same way it did before. So 3x minus 9 factors into 3 times x plus 3. And x squared minus 7x plus 10 factors into Same thing, x minus 2 times x minus 5 times 4x minus 8 factors into 4 times x minus 8 over, and that denominator factors into x plus 2x minus 2 times this numerator factors as well. 2x squared minus 6x plus 36 is 2 times x minus 6 times x plus 3 divided by, and very last thing is that x squared plus 3x minus 10 is going to factor into x plus 5 times x minus 2. Oops, and I made a mistake. I know, I'm sorry. That should not be an 8 there. That should be a 2. Okay, hopefully that's better. I think that's right. So again, I'm just looking for anything that's the same on the top and the bottom, anything that's the same in the numerator and the denominator. So the only thing that shows up in both of them is an x minus 2. And some of you are probably like, well, why'd you cancel out these x minus 2s, but last time you canceled out this x minus 2 with this x minus 2. The truth is it doesn't matter. There's two x minus 2s on bottom, so as long as one of them goes away, we're good. Which one of them did disappear? So then if we multiply this back out, or, well, kind of multiply it back out, we're not going to do all the multiplying. We end up with 24 times x plus 3 squared. Oops, sorry, that should be inside. Times x minus 6 in the numerator over, my denominator becomes x minus 2 squared times x minus 5 times x plus 2 times x plus 5. And I get some excluded values here. I have several of those. X cannot be positive 2, x cannot be positive 5, negative 2, and negative 5. So that would be my answer to problem 6. That's what problem I was on. Okay, I also had a request for problem, which one did I have a request for? Sorry, I'm trying to figure out if I did all the ones on the front page. I think I did. Maybe I did, maybe I didn't. I think I did do all the problems that I was asked to do on the front page. Oh no, problem 3. I heard that one was a struggle. Okay, so problem 3. I'm going to do that one next. And again, because it's got h of x in it, I'm going to have to do it twice. My request actually was from someone in 8th period, so I'm going to do this for 3rd and 8th first. So I have h of x, which is 2x squared minus 6x minus 36 over x squared minus 3x minus 10 times g of x, which is 4x minus 8 over x squared minus 4. So I need to factor everything, and at this point hopefully you've already figured out how all this factors, because it keeps factoring the same way over and over again. So 2x squared minus 6x minus 36 is 2 times x minus 6 times x plus 3. And then x squared minus 3x minus 10 becomes x minus 5 times x plus 2. And then times 4x minus 8 factors into 4 times x minus 2. And x squared minus 4 factors into x plus 2 times x minus 2. And again, we're just looking to see if there's anything that we can cancel. Anything that's the same on top and bottom. So we've got a couple things. We have an x minus 2 that's the same on top and bottom. Oh, and actually that's it. Nothing else. So that means my numerator now becomes 8 times x minus 6 times x plus 3 over my denominator is x minus 5 times x plus 2 squared. The reason it's squared is because I had x plus 2 here and x plus 2 here. And now I just need to figure out what my excluded values are, what x cannot be. So again, I'll look at anything that was ever in my denominator to decide that, which is this entire row right here. So that tells me that x cannot be positive 5, negative 2, or positive 2. If it's one of those three things, we're going to have an issue. If you are in my first period class, then your answer to this problem is going to look slightly different. I'm going to start at this step here, 2 times x minus 6. Let me write that a little bit smaller. Okay, so we'll have 2 times x minus 6 times x plus 3 divided by, and the way your problem is going to factor in the denominator, it is going to be x plus 5 times x plus minus 2. Those signs are going to be flipped. The numerators on the other side is still going to factor the same. So 4 times x minus 2 divided by x plus 2, x minus 2 in that denominator. So again, we're looking for things that cancel. Things are the same, both the numerator and the denominator. Well, you have an x minus 2 in both of them. So my answer to this one is 8 times x minus 6 times x plus 3 all over x plus 5 times x minus 2 times x plus 2, and x cannot be three things. It can't be negative 5, positive 2, or negative 2. So that's my entire answer to this question for those of you who were physically present in first period today. All right, I'm going to do a problem off the back. I need to check to make sure that I'm not getting any more messages. So thanks for catching my mistakes, guys. Youarethebomb.com. Sorry that I'm not perfect. I know I'm disappointing you, but I am human. I do fail. Despite what you may believe, I'm not perfect. Okay, so at this point, the entire front of your review is done, because I already did problem 1 in class for everybody. So the entire problem 1, like the entire front of your review is done. Now we're going to look at the back. And I said that I would do problem 10. That is the problem I said I committed to doing. So we have g of x equals h of x, and I'm going to have to do this one twice. I'm going to have to do this one twice because, again, it's got h of x in it, which is just throwing me off. So let's do it for first period first. So this is for those of you who are present in first period today. Only if you're present in first period does this apply to you. So our problem says g of x, which is 4x minus 8, over x squared minus 4, is equal to 2x squared minus 6x minus 36, over x squared plus 3x minus 10. So again, this is for those of you who are physically present in first period today. So we start factoring, and we have 2 times x minus, nope, sorry, I did this all day today, by the way. Every time I try to do this problem, I kept doing this. Let's try that again. That's 4 times x minus 2 divided by x squared minus 4, which is x plus 2, times x minus 2, is equal to 2x squared minus 6x minus 36. That factors 2 times x minus 6 times x plus 3 divided by x squared minus 3 plus 3x minus 10 is going to factor into x plus 5 times x minus 2. Okay, so once we cross multiply, we end up with 4 times x minus 2 times x minus 2 times x plus 5 equals 2 times x minus 6 times x plus 3 times x plus 2 times x minus 2. And I'm looking for things that are the same on both sides that I can cancel out. So I can cancel out an x minus 2 from each one, and that is it. On the left side, if you multiply that back out, you end up with 4x squared plus 12x minus 40. And on the right side, you end up with 2x to the third plus 2x squared minus 42x minus 72. And this problem, the only way to solve, well, not the only way to solve this, but the only way you would be interested in solving this, I'll say that, is to put this in Desmos and graph it and find out where they intersect, or get everything to one side of the equation and see where they intersect. Okay, hold on, I'm comparing my answer to someone else who sent me theirs earlier because we have a discrepancy and I'm trying to figure it out right here. I'm getting 42 and the other person is getting 48. Hold on, let me check the math. Because I definitely want to make sure that I'm doing this correctly. Because obviously we want to be right. Okay. Okay, that should be negative 48x right there. That should be a negative 48x. That's a terrible looking 8. We'll just do this. Look, there's a negative 48x. Okay, so that should be the answer to that question. Well, that's not the answer, but that's as simple as you can get it without graphing it. So normally what would happen is you would use quadratic formula, which we are going to be able to do when I do this the way that we do it with third and eighth period, because this is actually going to work out well, and we're going to end up with more stuff that cancels. So for those of you who got your review during third period or eighth period or some other time during the day that wasn't in first period, your problem is almost the same. The only thing that's different is in here when we factor, this x plus 5x minus 2 is flipped. So I'm going to go ahead and start here at this step just to save a little bit of time. So, because I know it's getting late, and I'm sorry that I'm keeping y'all at past your bedtime. 4 times x minus 2 divided by x plus 2x minus 2 equals 2 times x minus 6 times x plus 3. And the only difference for those of you in third and eighth period is that when you factor your h of x, you end up with x minus 5 times x plus 2. All right, so we need to cross multiply. So we end up with 4 times x minus 2 times x minus 5 times x plus 2 equals 2 times x minus 6 times x plus 3 times x minus 2 times x plus 2. We're looking for things that are the same on both sides that we can cancel out, and we've got several of those. We have an x minus 2 on both sides. Those are going to cancel. We also have an x plus 2 on both sides, so those are going to cancel. And I am left with, if I multiply this back out, 4x minus 20 equals 2x squared minus 6x minus 36. And I need to get everything to one side, because the only way to manipulate these problems, the only way to do anything with them, is to get all the x's on the same side. We're probably going to have to use quadratic formula. So I'm going to minus 4x from both sides. In the same step, I'm also going to add 20 to both sides. And I get 0 equals 2x squared minus 10x minus 16. You can factor out a 2 if you wanted to do that. It does help a little bit, just gives you smaller numbers. So really this becomes 0 equals x squared minus 5x minus 8. And then you're like, wait, where'd your 2 go? Okay, so all I did was I divided everything by 2. Remember, we can do whatever we want as long as we do it to both sides. So that means I can divide this left side by 2 as long as I divide everything on the right side by 2. And 0 divided by 2 is still 0. So that just gives me x squared minus 5x minus 8. Quadratic formula would be negative b. So 5 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And we have 5 plus or minus the square root. When you plug in the discriminant, you end up with 25 and 32, 57 in the discriminant. So my answer is x equals 5 plus or minus the square root of 57 over 2.